Today, we're counting words that have a unique appearance across two distinct lists. The challenge isn't just finding common words, but ensuring they appear exactly once in each list. How would you efficiently track and verify this specific frequency constraint? Given two arrays of strings, words 1 and words 2, our task is to return the number of strings that appear exactly once in words 1 and exactly once in words 2. If a word appears 0 times or more than once in either list, it does not count. We need to identify these uniquely occurring common words. A naive approach would involve iterating through each word in words 1. For every word, we'd then iterate through words 1 again to count its frequency, and if it's 1, we'd iterate through words 2 to count its frequency there. If both frequencies are exactly 1, we increment our total. This means nested loops for each word, leading to a time complexity of roughly n times n plus m, where n and m are the lengths of the word arrays. The repeated counting makes this highly inefficient, constantly rescanning the arrays. Space complexity would be big O of 1 constant time if we're not storing frequencies. The key insight here is that we need word frequencies. This immediately suggests using hash maps. We can build a frequency map for words 1 and another for words 2 in a single pass over each array. For each word encountered, we simply increment its count in the respective map. After populating both maps, we iterate through one of them, say freq1. For each word frequency pair, we check two conditions. First, if its frequency in freq1 is exactly 1. Second, we check if this same word exists in freq2, and if its frequency there is also exactly 1. If both conditions are met, we increment our final count. This avoids repeated scans by pre-calculating all frequencies. Let's trace with an example. Words 1, LeetCode is amazing as is words 2. Amazing LeetCode is. First, we populate freq1. LeetCode gets 1 as gets 2. Amazing gets 1 as gets 1. Next, freq2. Amazing gets 1. LeetCode gets 1 as gets 1. Now we iterate freq1. For LeetCode, its count is 1. Check freq2. LeetCode is present and its count is 1. Increment total. For its count in freq1 is 2. Skip. For amazing, its count is 1. Check freq2. Amazing is present and its count is 1. Increment total. For its count is 1. Check freq2. As is not present. Skip. We've processed all entries in freq1. Our final count is 2. The qualifying words are LeetCode and amazing, as they each appear exactly once in both of the input word lists. This confirms our logic for uniquely occurring common words. You'll spot this pattern whenever you need to count occurrences of elements, especially if you need to compare those counts across multiple collections or filter based on specific frequency criteria. Any problem asking for unique or single occurrence often points towards using a hash map for efficient frequency tracking. Time complexity is n plus m, due to single passes to build the maps and then iterating one map. Space complexity is n plus m for storing the two frequency maps. This hash map technique is fundamental for many string and array problems. Try the next problem involving frequency counting, same pattern. Don't forget to like and subscribe for more DSA insights.